With the short truth table, what happens when we're dealing with the long truth table is almost the same thing that is going to happen here. The only difference is that with the short truth table, you can resolve your argument in just one line. So you see that we still have the two definitions that will guide us. That if an argument is valid, it will be impossible for all its premises to be true and its conclusion false. So we begin with this definition. What you do is to write down the argument on a straight line, beginning with the premises and ending with the conclusion. So after doing that, you must proceed to render your argument invalid. You must do that. How do you render your argument invalid? You must tell us that all its premises are true and its conclusion is false. So because we already know that if an argument is valid, then it will be impossible for all its premises to be true and its conclusion false. So therefore, to render an argument invalid, you need to tell us that in fact the premises are all true and that its conclusion is false. Having done that, you rely on your knowledge of the truth values of logical connectives to give values to other variables in the argument. Having done that, you inspect your table for consistency and inconsistency. Now, when we talk about consistency, we are saying that you take a look at the logical connectives involved in your argument to see if they behave in the proper way. If they behave in the proper way, then it means they are consistent with your initial assumption. But when they do not behave in the proper way, then it means that they do not agree with your initial assumption. Remember, you begin by declaring the argument invalid. So consistency with your assumption will mean that the argument is in fact invalid, while inconsistency with your assumption will in fact mean that your argument is valid. So let's begin with the first example. We have P conditional Q, Q conditional P, therefore P wedge Q. So what you do is to write your argument on a straight line, beginning with the premises and ending with the conclusion. P conditional Q, Q conditional P, and then the conclusion, P wedge Q. The first step here is to render this argument invalid. How do you do that? You simply tell us that its premises are true, premise 1 is true, premise 2 is true, and that the conclusion is false. Having done that, you rely on your knowledge of the truth values of logical connectives to give value to other areas. You must do that. You must rely on your knowledge of the truth values of logical connectives, which means that if you do not have proper knowledge of the truth values of logical connectives, you cannot do business here. You cannot do business here. So it's very important. So take a look at this. We've already declared or rendered this argument invalid by saying that all its premises are true and that its conclusion is false. So having said that, you rely on your knowledge of the truth values of logical connectives. So you must begin from where you are setting. Otherwise, you will need to make assumptions and then probably discharge your assumptions. So this is a conditional statement. It is true. This is also a conditional statement. It is true. This is a disjunction. It is false. If you can begin from anywhere. But if you begin from here, you see that it is true here, but you are not sure of what happens. Like this, it is true here. You are not sure of what P is, you are not sure of what Q is. Because when a conditional statement is true there are three possible ways. There are three possibilities. So which of the possibilities are you going to take? Is it when they are both true, or when one is true, one is false, or when one is false, the other one is false and the other one is true? You are not sure. So it is the same thing here. It's a conditional statement and it's true. But when you begin from here where it is a wedge, you are certain. You are certain because it's a disjunction. And a disjunction is false when both disjuncts are false. A disjunction is false when both disjuncts are false. So we are very certain here that if this connective is false, necessarily, P is false and Q is false. So from here, you can distribute values to other variables. So it means that P here will be false, Q will be false, Q will be false, and P will be false. So that is how we come about distributing values here, where you have false, 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 all true. Because for this wedge, both disjuncts are false. If this is false, necessarily both disjuncts are false. So all other variables will be false. That is what happens here. So what we need to do now is to inspect our table for consistency and inconsistency. Remember, if there is consistency, it simply means that no rule guiding logical connectives has been violated. For that reason, the argument is invalid. Consistency, take note here, consistency means it is invalid, while inconsistency means it is valid. Don't mix it up. You may want to say, oh, if it is consistent, then it's valid. It should be valid. If it is inconsistent, then that's why it should be the other way. No. When there is consistency, it is invalid because it is consistent with your initial assumption that it is invalid. For that reason, it is invalid. When there is inconsistency, then it does not agree with your initial assumption that it is invalid, and for that reason, it is valid. So, you inspect your table. This is a conditional statement. It is true. When a conditional statement is true, is it possible to have a false antecedent and a true consequence? Yes. In fact, a conditional statement with false antecedent is true. For that reason, it passes here. There's consistency here. There's consistency here. So you come in here. It's also a conditional statement. It has a false antecedent and it is true. It means there is consistency here. There's consistency here. And this is a disjunction. It is false when both disjuncts are false. So there's also consistency here, which means there is consistency here, there's consistency here, and there's consistency here. There's consistency everywhere. So there is consistency. It means that this argument, what we have here, is consistent with your initial assumption that it is invalid, and therefore you said the premises are true and the conclusion is false. So for that reason, this argument is in fact invalid. When we move on to example 2, we have P conditional Q, therefore negation Q, conditional negation P. So what do? You simply begin by writing the premise first, and then the conclusion comes last. And then you declare it invalid by saying that the premise is true and the conclusion is false. Having done that, you rely on your knowledge of logical connectives to give values to other areas. You can't begin from here. It is a conditional statement. You are not certain, and it is true here. If it is true, there are 3 possible ways. But when it is false, you are certain that the antecedent is true and the consequent is false, which means that negation P will be true, while negation Q will be true, while negation P will be false. So if negation Q is true, it means that Q will be false. If negation P is false, it means that P will be true. So we move on now to present our values. Since antecedent is true, consequent is false, and this is also a conditional statement, it is false, which therefore means that The antecedent is true, the consequent is false. So negation P is therefore true. Negation Q, sorry. Negation Q is therefore true, while Q itself will be false. Negation P is false, while P is true. We have given values to all the variables here, so you therefore inspect your table for consistency and inconsistency. So you take a look at this. What you see here is a conditional statement. It is true. But we have here that its antecedent is true and the consequent is false. There is no way a conditional statement will have a true antecedent and a false consequent and it will be true. If a conditional statement has a true antecedent and a false consequent, it is necessarily false, which means that there is inconsistency here. This is not consistent with the truth values of logical connectives. So for that reason, there is inconsistency here. But when you come here, you see that the antecedent is true, consequent is false, it is false. There is consistency here, but there is at least a point where we have inconsistency. If you find inconsistency anywhere, whether here or here, anywhere, that argument is therefore valid, because what it means is that it is going against your initial assumption that the argument is in fact invalid. And for that reason, it is valid. So this argument is valid. So, still on the short truth tables, and then using the second definition for validity, which says that if an argument is valid, then its corresponding conditional must be tautologous. So, what you do, just like in the long truth table, you convert the entire argument to a conditional statement. How do you do that? You join all its premises together with the dot, a conjunction sign, to form the antecedent, while your conclusion becomes the consequent. Having done that, you plot your short truth table. After plotting your truth table, then you make an assumption. You make an assumption, right? What kind of assumption is that? You assume that the argument is in fact invalid. The argument is in fact invalid. And then you provide values for other connectives. After doing that, you inspect your table for consistency and inconsistency. You must do that. If there is consistency, then your argument is invalid. If there is inconsistency, then your argument is valid. So let's begin with this. Convert to a conditional statement and use long truth table to determine the validity or invalidity of the following argument. So we need to convert this argument to a conditional statement using the short truth table. We join the first premise and the second premise with a dot, a conjunction. We introduce the conditional sign, and then the conclusion becomes the consequent. So we have premise 1 dot premise 2 conditional the conclusion, which is now the consequent. So we bring that here on our table. That's what we have on our table. And then you begin by assuming that this argument is invalid. By this definition, since it's a conditional statement, you simply state that the argument is false and that its antecedent is true and the consequent is false. The antecedent is true and the consequent is false because it's a conditional statement. Unlike the other one where we just put the premises together on the straight line as well as the conclusion, we just said that all its premises are true and the conclusion is false. But this time around, it's a conditional statement. We say that it is false. The conditional statement is false and it's therefore invalid. So the antecedent is true. This is the major connective now for the antecedent, because this is the antecedent. We say it is true. And then we have our horseshoe, which is what connects the premises and the conclusion, which is now the consequent. Then you say the consequent is false. Having said that, you rely on your knowledge of the truth values of logical connectives. That's what you do. So you can begin from anywhere. If you begin from here, this is a conjunction. You are in fact comfortable. You can simply say that this is a conjunction. So for that, if this is a conjunction and it is true, it means that both conjuncts are true. This will be true and this will be true. Then you can go on to give values to that area. Then you can come here. This is a disjunction. Wedge is a disjunction. It is false. It simply means that both disjuncts are false. Both disjuncts are false. So which means that P will be false, and when you have P, it will be false. Q will be false, and when you have Q, it will be false. So that is why we can come here now. We've already said that the antecedent is true, the consequent is false. Since this is a disjunction and it is false, it means that both disjuncts are false. So P is false, Q is false. So it means that anyone who have P or Q, it will be false. That's why we have P false, Q false, Q false, P false. And then this is a conjunction, which is true. It means that both conjuncts are true. Both conjuncts are true. So you inspect your table now for consistency and inconsistency. Begin with this parenthesis, which is a conditional statement. A conditional statement with the first antecedent is true. A conditional statement with the first antecedent is true. That's the second parenthesis. And then for the whole bracket, this is a conjunction. A conjunction is true when both conjuncts are true, and it is true. A disjunction is false when both disjuncts are false. There is consistency here. For that reason, this argument is invalid, just like what we had when we were using the long truth table. And then taking a look at the second example. P conditional Q, negation Q, conditional negation P. So convert it to a conditional statement. The only premise there, which is premise 1, becomes the antecedent. You introduce your horseshoe, which is your conditional sign, and then the conclusion becomes the consequent. Put it on a truth table. Render it invalid by telling us that antecedent is true and the consequent is false. When you do that, with your knowledge of the truth values of logical connectives, you give values to other areas. This is false. You can't come here. You can't come here because there are 3 possibilities. But when you come here, you see that it is a conditional statement and it is false, which means that antecedent, if it is false, the antecedent is true and the consequent is false. So what that simply means is that negation Q will be true, therefore Q will be false. If negation Q is true, Q will be false. That's it here. If the consequent is false, negation P is false, then P will be true. So you see that antecedent is true, consequent is false. That's our assumption. Therefore, it is false. So we begin from where we are setting. It's a conditional statement. If it is false, necessarily the antecedent is true and the consequent is false. So from here we can give values to other areas. If negation Q is true, Q will be false. If negation P is false, P will be true. You inspect your table for consistency and inconsistency. This is a conditional statement. Antecedent is true, consequent is false. It should be false. It should be false, but it is true here, which means it is not consistent. It is not, there's a violation here. It's not consistent with our knowledge of the truth values of logical connectives. For that reason, this argument is valid because it is against our initial assumption that this argument is invalid. And for that reason, it is in fact valid. So this is very important. You must pay full attention to it and carefully study what we have here. Thank you.